Hi, so we have another question on command of evidence textual type. Let's read the question stem. Which finding, if true, would most directly undermine Foster's hypotheses? So, we know that this is a command of evidence question type by looking at the question stem, which mentions if true over here. And what do we need to do over here? We need to undermine Foster's hypotheses, right? So whatever this person's hypothesis is, we have to weaken it, we have to undermine it. So of course we'll have to know the hypotheses before we start understanding how to weaken this hypothesis, right? So let's go ahead and read the text. When digging for clams, their primary food, sea otters damage the roots of eelgrass plants growing on the seafloor. Now let's try and understand what's happening here, right? When digging for clams, so these sea otters are basically digging for clams. And what are clams? Their primary food source, right? They are finding the clams, and what do they do in order to find them? They damage the roots of eelgrass plants growing on the seafloor. So they damage the roots of this plant, right, which is growing on the seafloor. Now let's read ahead. Near Vancouver Island in Canada, the otter population is large and well established, yet the eelgrass meadows are healthier than those found elsewhere off Canada's coast. Now the previous sentence just told me that the otters, they damage the eelgrass plants, right? They damage the roots of the eelgrass plants. Now how is it that they are not doing the same in Canada, in this particular island, right? In fact, what is happening over here? They have this huge otter population, large otter population, yet the eelgrass meadows are healthier. So how is it that they are healthier and they're not getting damaged, right? This should be a question that you should ideally think of as soon as you read the second sentence. Let's read ahead. To explain this, conservation scientist Erin and colleagues compared the Vancouver Island meadows to meadows where otters are absent or were reintroduced only recently. Now these scientists, Erin and his colleagues, are trying to understand what's happening here, right? What is the explanation behind this? What did they do in that case? They basically compared the Vancouver Island meadows with the meadows where otters were not present or they were recently been introduced, finding that the Vancouver Island meadows have a more diverse gene pool than the others do. So what did they find? They found that the Vancouver Island meadows were more diverse, right? So because of this finding, they came to a certain hypothesis. Foster hypothesized that damage to eelgrass roots increases the plant's rate of sexual reproduction. So basically what is he saying? He's saying, when the eelgrass roots are damaged, the plant's rate of sexual reproduction increases. So something good is happening, right? This in turn boosts genetic diversity, which benefits the meadow's health overall. So overall, if I have to just create a crux kind of a thing out of this hypothesis, I would say that when the damage to eelgrass roots are done, a positive impact has been seen on the plant. So damage to eelgrass roots is good for the plant's overall health, the meadow's overall health. Right? Now, in order to undermine this or weaken this, what do I need to do? I need to say that Foster is wrong, right? I need to say that there's some problem with his hypothesis, which basically means that I have to say that the damage to eelgrass roots is not good for meadow's health overall. Right? I have to find some flaw in his whole plan, in his hypothesis. Now, let's see what the options have given me. A. At some sites in the study, eelgrass meadows are found near otter populations that are small and have only recently been reintroduced. Now this basically is just talking about some sites in the study, and what happens in these some sites. The eelgrass meadows are found near otter population, and what kind of an otter population we are talking about? Small. However, the text is talking about the larger otter population, right? Not the small ones. So I don't think this is relatable to the text, right? Because they're talking about the large otter population, not the small ones. So this is definitely out. Also, if you notice, this particular option is just talking about where eelgrass meadows are found. Right? When it comes to the otter population, where are they found? However, that is not what I'm trying to prove. I'm trying to find a problem in Foster's hypothesis. I'm trying to say that his hypothesis is incorrect, right? So I'm going to eliminate this anyways. This is out of context or not relatable. Now B says at several sites not included in the study. So we are talking about the sites that are not included in the study. There are large, well-established sea otter populations but no eelgrass meadows. So they're saying that, you know, in these sites there are large sea otter populations but there are no eelgrass meadows. So this is again out of scope. Why? Because I'm looking for a relationship between the otter population and the eelgrass meadows. And if the eelgrass meadows are not there, the whole relationship can't be understood. So I'm going to definitely eliminate this option as well, because it's not telling me anything about the relationship. The eelgrass meadows are not even there, right? So I'm going to go with C now. At several sites not included in the study, eelgrass meadows health correlates negatively with the length of residence and size of otter populations. Okay, now this is talking about something negative. Now what is it? What is happening here? You know, the eelgrass meadows health correlates negatively. So there is a negative relationship between the eelgrass meadows health and the duration and the size of the otter population. So more the duration of the otter population, more the size of the otter population, worse the meadows health, right? There's a negative relation between both the things. So this is kind of telling me something's wrong with this hypothesis created by Foster, right? So this is definitely undermining his hypothesis. I'm going to keep it for now, and let's go ahead and see what happens in D. At some sites in the study, the health of plants unrelated to eelgrass correlates negatively with the length of residence and size of otter populations. Now, first of all, this is talking about some sites in the study. Few sites probably won't have a lot of significance over here, but let's see what it's saying. The health of plants unrelated to eelgrass. Now they're talking about some other plants, right? The health of plants unrelated to eelgrass correlates negatively. Now, what is happening with these other plants? I don't think I'm concerned about that. I'm only looking for the relationship between the eelgrass and these otters, right? I don't care about the health of other plants. So this is also out of scope, irrelevant. So you've got your answer. C is clearly undermining Foster's hypothesis.